That is a signal detection methods in the pharmacovigilance. We have a different method for the signal detections: denominator-based methods, observational epidemiological methods, numerator-based methods, proportional reporting ratios (PRR), and Bayesian data mining. For the denominator-based methods, we have a cumulative sum, time scan, and Poisson's method. Cumulative sum, time scan, and Poisson's method. For the observational epidemiological methods, actually we explain in the other videos. I don't want to go deeper on these explanations. For the numerator-based methods, we have a short memory schemes, numerator-based methods, and for the Bayesian data mining, we have a Bayesian confidence propagation neural. We have a Bayesian confidence propagation neural network (BCPNN), and we have a empirical bias screening or EBS. Okay, again, Bayesian confidence propagation neural network. This is a one method for signal detection methods, and empirical bias screening or EBS. This is another signal detection method. These are the different methods. This is articles, original reports applying quantitative methods for detecting new drug safety signals in pharmacovigilance national database from Iran, from Dr. Gloria Shalviri, Dr. Kazem Mohammad, and Dr. Reza Majzadeh, and Dr. Khairullah Gholami. This is the original report. Okay, the proportional reporting ratio, it's another signals method, 2 by 2 contingency table, and we want to explain this, how it's work. The ADR of interest and other ADR. We have a drug of interest as A and other drug as C. Okay, you see, this is a table, we have it, 2 by T contingency table. The drug of interest and the ADR of interest is A. The other drugs and the ADR of interest is C. The drug of interest and the other ADR is B. The other drugs and other ADR is D. The proportional reporting ratio is A divided by A plus B divided by C divided by C plus D. Okay, the PRP, A divided by A plus B. This is one proportion, and all of this divided by C divided by C plus B, D. A divided by A plus B by C, C plus D. Sample, same formula as relative risk as used in pharmacopoeia studies. Same formula as relative risk as used in pharmacopoeia studies. Okay, this is a proportion reporting ratio. Reporting odds ratio, what does it mean? This is again 2 by 2 contingency table, and again drug of interest and ADR of interest is reporting as A. Drug of interest and other ADR, the other ADRs of my drug interest is B. The ADR of interest of other drugs is C, and other ADRs from other drugs is D. Reporting odds ratio or ROR. is A divided by B divided by C divided by C. Same as odds ratio as used in pharmacopoeia studies. What is Bayesian statistic? What is Bayesian statistic? An alternative statistical approach derived from Bayes' law used the probability to express subjective degree of belief in a specific outcome. Use probability to express subjective degree of belief in a specific outcome. Current probability based on prior belief data constantly updated on addition of new data. Constantly updated on addition of new data. An alternative statistical approach derived from Bayes' law use probability to express subjective degree of belief in a specific outcome. Current probability based on prior belief data and constantly updated on addition of new data. This is a Bayesian statistic. Question: you arrive on holiday in Dubai, longing for a hot holiday, a city built in the middle of desert. But as you walk out of the airport, it is raining. You believe that is 100% likely to rain the next day? No. Dubai is in the desert. It can't rain that often, can it? For your knowledge. But because it rained today, it must seem more likely than before. You saw the rain. A rainy reason. Cloud is still around, but your belief in the chance of the rain is between your original belief and 100%. Philosophy of Bayesian statistic. For example, prior probability, the probability of rain tomorrow in Dubai, and data, you arrive in Dubai and it's raining. Posterior probability, the probability of rain in Dubai given that it rained today. Without including prior knowledge, we are oversensitive to data. Without including prior knowledge, we are oversensitive to data. Philosophy to Bayesian statistic, ADR data, prior probability, drug ADR combination, weakly assume unrelated. Drug ADR combination, weakly assume unrelated. Data reporting to the ADR database and posterior probability. Drug ADR combination related, given prior and reporting to the database. Given prior and reporting to the database. Without including prior knowledge, we are oversensitive to data, leads to false signal. Without including prior knowledge, we are oversensitive to data. Without including prior knowledge, we are oversensitive to data, leads to false signals. Frequent estimate of IC, 2 by 2 contingency table, ADR of interest, and other. Okay, you see, in these tables, we have ADR of interest and ADR of a drug of interest. If the ADR of drug my interest and the ADR of my interest is A, and the others is B, and my others drug, ADR of my others drug, and this my ADRs of interest is C, and my others ADR and my others drugs, it means my I have others drug and I choose my others ADR is D. Now the IC is log in the base of the 2 in the A divided by A plus B multiplied by A plus C divided by A plus B plus C plus D. Again, you see, I should choose, for example, the DRA of my loperamide. This is my ADR of my interest, of my drug of interest. And constipation, this is the other ADR of my loperamide. And the DRA of my levothyroxine, this is my other drug. And the constipation reported from my levothyroxine, this is D. This is others from the others. Constipation is others from the loperamide, drug of my choice. And this is others drugs. This is what I understand it from the frequent estimate of IC. And IC means information components. Okay, again, maybe I have a 2x2 contingency tables. I have a drug of interest and others drug, and I want to get the frequent estimate of information components, and I want to get the log. In this case, the log is observed divided by expected. Log is observed divided by expected. Okay, the information components I see, and the definition and properties. IC is a measure of disproportionally used for analyzing the WHO database, calculated in Bayesian framework, in Bayesian confidence propagation neural network BCPNN. Used within Bayesian statistics framework allow us to have useful dampering property. Okay, again, information component is IC. IC is measure of disproportionally used for analyzing the WHO database and calculated in Bayesian framework, in Bayesian confidence propagation neural network BCPNN, used within Bayesian statistic framework allow us to have useful dampering property. Question. Okay, no, I read the question. No, I coming here. IC interpretation. In the IC interpretation, we have a base 2 logarithm, and if the IC will be 0, it means the observed number is equal to expected number. If the IC will be 1, it means the observed number is equal to the 2 to the power expected number. If the IC will be 2, it means the observed number is 4 times of the expected number. And if the IC will be 3, it means the observed number is 8. I don't understand. This is 8 to the power of the expected number or 8 multiplied by the expected number. It's a little bit confusing. And if the IC will be 4, the observed number is 16 of the expected number. And if the IC will be 5, the observed number is 32. And why? Because it was the log in the base 2. Observed divided by expected. A plus B multiplied by A plus C divided by A plus B plus C plus D. Okay. IC interpretation. If the IC will be 0, that the observed and expected is equal, the combination reported as often as expected relative to background of DB if drug and ADR are independent. If the IC is 0, combination reported as often as expected relative to background of DB if drug and ADR are independent. And drug and ADR are independent because the observed and expected are equal. Is the riddle. If the IC is more than 0, the combination reported unexpectedly frequently. If the IC is less than 0, combination reported unexpectedly infrequently. If the IC 25D more than 0, 95.5% chance that IC is greater than 0. Highlighted for clinical review. If the IC, that one. IC 25D more than 0 and 97.5% chance that IC is greater than 0. This interpretation is really hard for me to understand. I should search more. Example of WHO signal generated by data mining: topiramate and glaucoma, spring 2001, and antipsychotic 2001, antipsychotic and myocarditis, spring 2001, olanzapine and granulocytopenia in 1998. Decide on priority, give a birth priority to series of fetal case, series of cases of serious unexpected reaction, series of serious labeled reaction, series of unusual reaction. Again, decide on priority, give a high priority to series of fatal case, death. If you have a death, this is a priority and high priority. Series of case of serious unexpected reaction, series of serious labeled reaction, and series of unusual reaction. Follow-up. Review impact of the intervention. Further case reported. Repeat the message. New intervention necessary. PSUR section. Overview of signals, new, ongoing, or closed. A signal should be included once it has undergone the initial screening or clarification step, and a determination made to control further evaluation by the marketing authorization holder. Overviewing of signal, new, ongoing, or closed, undergoing to overviewing of signals, new signals, ongoing signals, or closed. A signal should be included once it has undergone the initial screening or clarification step, and a determination made to conduct further evaluation by the marketing authorization holder. Signals may be qualitative, for example, a pivotal, individual, case safety report, case series, or quantitative, for example, disproportionality score, finding of a clinical trial, or epidemiological study. Signals may be arise in the form of an information request or inquiry on a safety issue from a competent authority worldwide. Okay, you see again, signal may be qualitative, for example, pivotal, individual, case safety report, case series, or may be quantitative, disproportionality score. Maybe we have finding of a clinical trial or epidemiological study. Signal may be arise from the inform of information request or injury on a safety issue from a competent authority worldwide. Okay, new signal. New signal. A new signal refers to a signal that has been identified during the reporting interval, where new clinically significant information on previously closed signal becomes available during the reporting interval of the PSUR. This would also be considered a new signal. A new signal refers to a signal that has been identified during the reporting interval, where new clinically significant information on a previously closed signal becomes available during the reporting interval of the PSUR. This would also be considered a new signal. New signal may be classified as a closed or ongoing, depending on the status of signal evaluation at the end of the reporting interval of the PSUR. New signals may be classified as closed or ongoing, depending on the status of signals evaluation at the end of the reporting interval of the PSUR. Examples of new signals would therefore include new information on a previously closed and refused signal. Closed and refused signals and refuted signal or refused, I don't know, that's the refute or refused, which in the closed and refuted signal, which would result in the signal being reopened. Example of new signal. Identify risk, where the new information suggests a clinically significant difference in the severity or frequency of the risk. For example, transient liver enzyme increase or identify risk and new information indicative of a more severe outcome, such as hepatic failure is received, or neutropenia is an identified risk and a well-documented case report of granulocytosis with no presence of possible alternative cause is received. Okay, again, identify risk where the new information suggests a clinically significant difference in the severity or frequency of the risk. For example, transient liver enzyme increase or identified risk and new information indicative of a more severe. Identify risk for which a higher frequency or severity of the risk is newly found, for example, in an indicated subpopulation. Potential risk which, if confirmed, would warrant a new warning, precaution, a new contraindication, or restriction in indication or population or other risk minimization activities. Okay, if we have a potential risk, if confirmed, would warrant a new warning, precaution, a new contraindication or restriction in indication or population or other risks minimization activity. New signal refer to a signal that has been identified during the reporting interval, where new clinically significant information on a previously closed signal become available. A new signal may be classified as closed or ongoing. Okay, tabulation of all signals ongoing or closed at the end of the reporting interval. A brief description of the signal. date when the marketing authorization holder became aware of the signal, status of the signal at the end of the reporting interval, close or ongoing. A brief description of the signal. Date when the marketing authorization holder became aware of the signal, and a status of the signal at the end of the reporting interval, close or ongoing. Date when the signal was closed, if applicable, and source of the signal. Brief summary of the key data. Plans for further evaluation and actions taken or planned. Okay, what does it mean? Now we want to tabulate all of our signal we have, that they are maybe ongoing or close at the end of our reporting interval. We need a brief description of the signals. We need date when the marketing authorizations holder became aware of our signals. Actually, we should warn them. A status of the signals at the end of the reporting interval, and date when the signals was closed. We should date them, and if applicable, source of the signal. What is the source of our signals? A brief summary of the key data, plans for further evaluation and action taken. Okay, see this here, the source. Actually we have a different source. We have source of the signal may was the observation in individual patients, or observation in population, or experimental finding. Okay, tabular summary of safety signals that were ongoing or closed during the reporting interval. Signal term: a stroke. Date detected. We should record it. Status: ongoing or closed. This is ongoing. Date closed for closed signals. Source of signal is meta-analysis, or for example published serial something, etc. Reasons for evaluations and summary of the key data. A statistically significant increase in frequency, for example. Method of signal evaluation. Review meta-analysis available in data. Action taken plan pending. SGS, signal term is SGS, Stevens-Johnson syndromes. Date connected. We should write the date. Status: ongoing or closed. This one is closed. Data of the closed or ongoing signals. Source of the closed: spontaneous case reports. Reasons of evaluation. Rash already and identify risk. Stevens-Johnson syndrome not reported in pre-authorization. 4 report within 6 months of authorization. Plausible time to onset and no possible alternative cause. Targeted follow-up of reports with site visit to one hospital, full review of cases by MAH, dermatologist, and literature searches. RSI updated with a warning and precaution. DHPC sent effective survey plan 6 months post DHPC, and RMP updated. Okay, signal evaluation. Those signals that following evaluation have been refuted as false signal based on medical judgment and scientific evaluation of the currently available information. Those signals that following evaluation have been categorized as either a potential or identified risk, including lack of efficacy. Okay, for the signal evaluation, first, those signals that following evaluation have been refuted as false signal based on medical judgment and scientific evaluation of the currently available information. Those signals that following evaluation have been categorized as either a potential or identified risk, including lack of efficacy. Classification of closed signal. Closed and refuted signal. Closed signal that are categorized as important potential risk. Closed signal that are categorized as important identified risk. Closed signal that are potential risk not categorized as important. Closed signal that are identified risks not categorized as important. Again, you see close. Refuted signal as important potential risk, as important identified risk, as not categorized as important, not categorized as important. You see the potential risk not categorized as important, identify risk not categorized as important. Oh, it's difficult. Again, categorized risk that are categorized as important, as important potential risk, categorized as important identified risk, or potential risk not categorized as important. You see, important potential not as important,